Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 20, 2014 JEE Advanced Physics Paper 1, Code 8. So let us solve question number 20. So let us solve question number 2020. Question is from thermodynamics. A thermodynamic system is taken from an initial state I with internal energy 100 joule. So this is the initial state I is taken from this to the final state F. Here is F with internal energy 100 joule. So starting with it has internal energy 100 joule to final state F along two different paths I, A, F. This is one path and this is second path I, B, F as shown in figure. The work done by the system along the path AF, work done by the system along the path AF, IB are this and this respectively. So work done by AF and IB are this. So work done by AF is 200 joule and work done by IB this path. So AF is this path. Work done by IB along this IB it is 50 joule. And work done BF from B to F. Suppose this is B and B to F. Work done by BF is 100 joule. Okay. The heat supplied to the system along the path IAF, along this path, the heat is supplied to the system. The heat supplied to the system along the path IAF, IB, and BF are this and this respectively. So heat supplied along IAF, IB, and BF are this and this and this respectively. So this is where you supply, this is where you supply. This is heat in IAF path. This is the amount of heat that you have supplied here, and this is the heat supplied here, and this is supplied here. All different. Now, if the internal energy of the system in the state B is UB, in the state B, here the internal energy is UB, which is given as 200 joule, and QIAF, IAF, the heat that is supplied here in this process is given QIAF is 500 joule. Then we have to find the ratio of QBF upon QIB. This is what we have to find. Now, if you draw the diagram properly, this is the initial point, this is the final point. This path is something like that up to B, then some path is like that. This is B, this is A, IAF, IBF. Now in the question it says that during this IB, IAF, the heat you are supplying IAF is given as 500 joule. So IAF is given as 500 joule. Here the potential energy at B, UB is 200 joule. Okay, and from UA is not given, and work done during work done during WAF, AF, here the work done here it is doing work done is only this path is AF is 200. Work done during IB, from here to here the work done is IB equals to 50 joule. BF, the work done is also given. BF, here the work done is 100 joule. And so these are the work done 1, 2, 3, and so heat is given. And U initial, this also is given. UI is given as 100 joule. U final is not given, so these are the data given to you. UB is 200, UI is this, UQAF is given. So there are 1, 2, 3, 4, 5, 6, 6 data are given. 1, 2, 3, 4, 5, 6. Now you have to find the ratio finally of QBF. That means BF path is this. How much heat that is supplied in this path? QBF divided by QIB. So this heat supplied during this part, that is QBF, and supplied during this part QIB. You have to find these two and divide. Now because we know that the internal energy or the change in internal energy of the system is independent of the path followed. If even if the object is the system is carried from in this path or this path, the change, because of the initial and final condition of these two paths are same, so the change in internal energy will be same. So let us find the first, use this one because everything is given for this. So you will find the change in potential energy involved during this path. Because the work done during this path will be 0, obviously from WIA I will write 0 because this is vertical line. WIA I will write 0. So I know the total work done, I know the total heat supplied, so I will find the change in the potential and internal energy. Whatever will be the change in the internal energy in the first case, that will be the change in internal energy for the second case, this case also. So first I will use this path IEAF and find the change in internal energy. So using the first law of thermodynamics, we have the amount of heat that is supplied is change in internal energy plus some work done external. The heat that we are supplying during this path is 500 joule, so this is IAF, and this is IAF, and this is IAF. This is 500 joule given, and change in internal energy UIAF to find, and this is W, the work done. The total work done is WIA plus WAF, WIA plus WAF. And because this is there is no work done during this process, okay, because this is a PV diagram, and this vertical line has no area under this curve, this has an area under this curve, so this it has work done which is 200 joule, and this work done is 0. So this is plus 0 plus this is given as 200. This is given in the question 200. So I get the change in internal energy in the first process from IAF, I to F following this A path, that comes out to be 300 joule, because 500 minus 200 is 300. If that is the internal energy change, so here it is 100 and here it is then the change is 300. The change in internal energy in this process 300. If it is 100, then it will be obviously 400, so the change will be 300, so it will be 400 here. So the change in internal energy when the system is carried from this path or this path here it is found to be 300. That means internal energy at this point, if needed, is 400 joule, because the difference will be 300, because the difference we've got as 300, so therefore it should be 400 joule. Now we have to find the follow this path, because we're interested in the heat that is given or supplied during this process. So therefore I will use the formula, again the same formula, first law of thermodynamics in this case. So I'll use for the second case, for the path IBF, I am going from here to this point, and this is I, this is B, and this is F. So in between IB, the heat supplied is IB, and here it is QBF. So in this case, I'll apply again the change in the heat that is supplied. The heat supplied IBF is the change in internal energy IBF plus the work done delta W IBF. This IBF is same as IAF, because the internal energy change doesn't depend upon the path followed, so this will be 300 joule plus W delta W IBF. IBF is the sum of the work done by these two processes, so it is IBF. In the question is given how much, WIB is given, WIBF is given, so I'll write WIB plus WIBF. The total work done during this process is the sum of the work done during these two individual work done, and this is given as 300 plus WIB is given as I can see here 50, and here it is 100. So it is 50 and here it is 100. So this comes out to be 450. So the heat that is supplying in this case is 450. Okay. Now if this is 450, then our aim is to find the heat supplied during that process. So I got this heat, the heat that is supplied during this process from IBF, and that is that we got as, so in the second case the heat that I am supplying IBF equals to 450 joule, and you can see that if this is the amount of heat that I am supplying, and the change in internal energy is 300, then 150 must be the work done. Now individually in I to B, how much heat is given, and this how much heat is given in this process. To do that, I must know about the internal energy situation, because I know the work done, so the heat supplied will be obtained. So here from I to B, this part of the curve I to B, I have to apply the first law of thermodynamics again. If I apply first law of thermodynamics again, then to this path I will write that the heat supplying during this process from IB equals to change in internal energy IB plus work done IB. Because I have I equals to UI is 100 and UB is given 200. UI is 100 and UB is 200, that I've already written here for the sake of convenience. So change in is 100. So this is 200 minus 100. The change in internal energy in this process when you move from I to B is this, plus work done during this process is 50. So QIB is coming out to be 100 plus 50, that is 150. So QIB is 150 joule. Now next part of this path I have to apply again. In this path I have to apply the first law of thermodynamics. During this path is F. So if I apply first law of thermodynamics to this path, this point is having internal energy 400 and this is having internal energy of 200. You can see here the internal energy here is 200, here it is 400 because this is difference is 300. So 200 is the potential energy difference, internal energy difference. So these, if I apply the formula, then I will have to the applying first law of thermodynamics to the path BF. So during that BF, the heat I am supplying during BF must go into the change in internal energy of BF plus the external work done in BF. If I want to find this QBF, the QBF is the question. This DQBF or QBF, that is a change in internal energy. As you can see here, it is 200 to 400, so it is 400 minus 200 plus the work done that we have already got. Here is given in the question, the work done is 100 joule BF, so it is 100 joule. So it is 200 plus 100, it is 300 joule. So that means this I am supplying here I am getting 150 and this I am getting 300. Okay, because IB I got to 150 here and this I got now, this is 300. This is 300. Now the question is to find the ratio of QBF upon QIB. QBF upon QIB means the heat are supplying in this case and heat are supplying in this case. That ratio, that two. This we got, and already we got QIB, QBF upon QIB. This we got as 300 and this we got as 150. So the answer is 2. So the answer to this question, the ratio is how much? The answer is 2. This is the answer to this question. Okay, thank you.